Hello everyone, greetings for the day. This is the CodeBot application which has been created by our team. It is CodeBot, the Quantum Sentinel. So this CodeBot has been created by our team members are Barun, Nikhar, Sagar, Anusha, and Moti. So I'll start with the implementation which has been implemented in this Python code. So starting with the folder path, which is being referenced to the resource folder, and this resource folder holds nothing but all the uh, code files. Basically, for the POC, we have taken the Java files, and if you see in this PDF, the whole Java files are being uh, stored in the PDF format, and as well as we have the SQL file in the resources folder. So I'll start with the implementation of how it goes. So in this first method, we have load and chunk PDF method. In this, nothing but we are doing the PDF documents are read and then split into smaller chunks of texts. The next we have prepare embeddings. For this method, here we are here the embeddings are being generated, and each text is converted into a vector embedding that represents the meaning of that text. Okay, so then after that we have an FAISS embeddings. So FAISS basically FAISS indexing. So these embeddings are indexing. These embeddings are indexed using FAISS for efficient retrieval. Let me tell you what FAISS is. It is Facebook AI similarity search. So what this FAISs do is basically it is being used to enable fast and semantic search of the text chunk so that the most relevant sections of the PDFs can be used to answer the user's questions accurately that is being input onto the chatbot. So that is what FAISs is. Then we moving to the next part of the code, basically where the user query is being taken, and when a user asks the question is also converted into an embedding. If you see here that we are iterating to it to the chunks, and then we are using the nearest neighbor search. Basically the FASS searches for the text chunks whose embeddings are closest to the user's query embedding, so which the input was converted into the embeddings as well, so that is being searched here, and based on that it will feed it to the LLM. Well, come to the LLM part. So what we are doing is in the next part is we are doing a response generation where the most relevant text chunks are passed to the LLM. For our model, we are using Gemini 1.5 Pro LLM model. If I show you here, this is the model, and that is being used for the and generation of the output to like coherent and informed responses from the LLM. So what this configuration implies here is that the temperature is one. Basically, temperature is nothing but the preciseness and the concise of format of the output that will be generated by the LLM given by the depending on the input that has been provided by the user. And we have also taken the constraint here for maxed output tokens because in LLM we have restriction over the tokens that are being given as an input or as well as output. So for every given input, those words or text are being broken into tokens. So that is all what about the implementation here. And let me give you a walkthrough over the demo. I'll start with the command of Streamlit. So Streamlit is nothing but a web interface that we have used where our output of the LLM response will be shown and of our chatbot. Let it process the whole code and will give us the prompt where we can. give the prompts. So here I'll show you a prompt which can be used. So if we see here, we have a prompt, let's say this prompt, and okay, we'll give it. Uh, this input will be broken into tokens, which is being understood by our LLM. As you can see now, the output has been generated and the code is there. Then we have the explanation also. You see SQL query and what all it do, right? Then data mapping, values, error handling, what it is doing, distance obtained, max emission, how it is calculating everything, and how the emission object is created. So at last, we're getting a summary. In essence, this code retrieves calculate data about data displaying user rank by their accumulated lead points. So it calculates carbon emission and lead points for a given trip, providing insights into individual contributions to the leaderboard. If I show you another question based on this, so here, if you see, the output has been generated with the intelligence of our model Google Gemini 1.5 Pro. You see, the explanation is generated with the English format, and everything is explained in the layman's language, which anybody can understand. As you see, calculation methods, placeholder methods, then some uh, additional suggestions are being provided over that. So, so basically, as now you can see, we have now provided you the now provided the SQL question based on the trip data table. It is providing us the output on the database schema. So it is intelligently referring to the particular document, which is pointing to an SQL queries which are written. Basically, if you see in the resources folder, we have database SQL file, and it's directly going into that particular document which has been pointed, and then giving us the output with the intelligence of the LLM used. If you see here, the mode of the transportation used, everything whichever the trip data table holds that particular information has been provided into English, easy language, understand by all. Could be a business analyst, ops guy, anyone can be easily understand by this particular output. And yes, so this now, as you can see, our implementation has changed onto the GitHub URL. So what it will do is it will first ask the user to input the URL of the GitHub, and then that GitHub URL will be passed to download the file from GitHub and have it ready to read and give the output from that. So if you see that download file from GitHub is doing that particular operation. And then the same method, load and chunk file, will break it all the chunks. Basically, what it will do is, and that downloaded file will be then changed to the PDF format or text format, and then it will be break into chunks. And the rest operations are same. Uh, if I show you how the code looks like, the demo codebot. Uh, Here we are providing the GitHub URL till the emission services.java, which is, if you can see here, this file has been provided on this link Java file URL of GitHub. And then we are good to start with the questions. If you see, I have asked the question, please explain me the code logic to a 5-year-old written in emission service class. So if you see here, all the code is being provided here, whichever was written in that particular class. Then we have the explanation. This explanation is generated with the Facebook AI similarity search FAIS with the help of that. And then we have a sentence transformer that is being used for the better generation of sentences from the from the input that a user has tried to query. Here, if you see the transfer and that model which has been provided, help AmpNet base V2, basically it is used to generate the embeddings with a more precise and concise manner. And then those precise embeddings are being uh, passed through FAISs, and then from FAISs, those are being passed to LLM, which is Gemini 1.5.4. With its intelligence, we are getting a precise and concise output on our output screen in the simple English language format, which is this code defines as an emission service responsible for calculating and saving carbon emission data for trips. Here's the breakdown. And all the breakdown is been provided. Every method, what it does and what it is doing. And then in the end, we have the summary. In essence, the code takes trip information, calculates carbon emissions and associated lead points, rewards, and persists this data for later analysis or use. Yeah, that's it. Thank you for your time.